Have you ever just stopped and wondered how a massive system like Facebook or Amazon actually works? I mean, it seems impossibly complex, right? But what if I told you we could figure out the core principles just by designing something, well, a lot more delicious? Let's dive in and build our very own pizza empire right from scratch.
You know, the journey to serving millions of people always starts with just one. So let's picture it. Our business in its simplest form. A single tiny pizza parlor. We've got one customer, they've placed one order, and we've got just one chef to handle the whole shebang. This is our ground zero.
So, here we are in phase one. Everything, and I mean everything, revolves around our one single star employee. They take the order, they make the pizza, they serve the customer. It's simple, it's effective. But, as we're about to find out, this setup has its limits.
And just like that, business is booming. The word is out, more customers are piling in, the orders are stacking up, and our one chef, well, they're starting to get overwhelmed. This is our very first scaling problem. Our single resource has become a bottleneck. So what's the first thing you do?
Now you might be thinking, just hire more people, but hold on. The first move is usually way simpler. Make the resource you already have more powerful. You pay your chef more to work a little faster, you buy them a bigger, better oven, and you streamline their whole pizza-making process.
And in the world of system design, this has a name. It's called vertical scaling. It's all about beefing up a single component. Think of it like giving your computer more processing power or more memory. It's just like giving our one chef that top-of-the-line super-fast oven.
Now this is where it gets really interesting, because these simple kitchen optimizations map directly to technical concepts. Pre-making all the dough at 4 a.m. when there are 0 customers, that's basically the same thing as running a batch job or creating a cache during off-peak hours, so you're totally ready for that dinner rush.
Okay, so we've done it. We've created a super chef. They're fast, they're efficient, they're making the best pizza in town. But we've overlooked a huge, critical flaw in our design. If our one and only chef can't come to work, what happens to our business for the day?
Yeah, it closes. That's it. Lights out. Our chef is what we call a single point of failure. It's that one piece of the puzzle that if it goes down, the entire system just grinds to a halt. It's a massive problem. So how do we fix it?
The solution is actually pretty straightforward. Redundancy. You hire a backup chef, someone who knows all the recipes and can step in the second your main chef is out. In the tech world, this is like having a backup server ready to take over if the main one fails. No more closing up shop just because someone's got the sniffles.
All right, so our business is resilient now, but it's still growing like crazy. A super chef and their backup can only make so many pizzas. To keep up with this insane demand, we've got to fundamentally change how we think about this. It's time for the next phase.
This right here perfectly lays out the two big strategies. On the left, you've got vertical scaling, our one super chef. Super powerful, sure, but they have their limits, and they're a single point of failure. But look at the right, that's a different idea entirely. Instead of one super chef, what if we hired a team of 10 regular chefs? Now, if one gets sick, we've still got 9 others working. This is a total game changer.
And this strategy, it's called horizontal scaling. Instead of making one machine bigger and more powerful, you just add more machines to your system to share the workload. You're spreading the work across a whole team. And that's not just more resilient, it's way easier to expand as you grow.
Okay, so we've got a team of chefs. Awesome. We can handle a ton of orders now. But, of course, a new kind of problem starts to pop up. We're not just a pizza place anymore. Our menu is getting bigger, and that means we need a whole new level of organization.
So let's say some of your chefs are pizza masters, right? Absolute artists. And others are wizards with garlic bread. If you just hand out orders randomly, your pizza expert might get stuck making garlic bread all night, and that slows everything down. So how do you manage this kind of specialization?
You create a system. It's pretty simple, really. When an order comes in, someone up front identifies what it is, pizza or garlic bread, and then sends it directly to the right specialist team. This way, your experts are always doing what they do best, which makes the entire kitchen way faster and more organized.
And believe it or not, what we just described is the core idea behind something called a microservice architecture. Instead of one giant, clunky application that does everything, you break it down into small, independent services. One service handles user profiles, another one handles payments. Just like our kitchen has a pizza team, a garlic bread team, and a drinks team, each responsible for just one specific thing.
So our one shop is now a well-oiled machine. It's scalable, it's resilient, it's super efficient.
But it's still just one shop. All our eggs are in one single basket. To really protect our business and serve our customers better, we've got to think bigger. Just think about it. A power outage in the neighborhood, a water main break, even some issue with a permit, any one of those things could shut down our entire operation. The shop itself has now become our new single point of failure. The solution? We have to distribute. By opening a second shop in a different part of town, we get two huge advantages. First, fault tolerance. If Shop A has a power outage, no big deal. Shop B can pick up the slack. And second, quicker response times. Shop B can get pizzas to its local customers way faster, which, in the real world, is just like reducing latency in a computer network.
But now, when a customer calls, which shop gets the order? Well, you need a central dispatcher, right? This dispatcher is our load balancer. And it doesn't just route things randomly, it makes a smart decision. It'll check the wait time at each shop, look at the delivery distance, and send the order to whichever shop can get that pizza to the customer the absolute fastest.
So, let's just take a step back and look at what we've actually built here. We started with one single chef in a tiny shop, and we ended with a sophisticated, distributed network of pizza places. Every single step we took to solve a real-world business problem has a direct parallel and high-level system design. It's pretty cool.
This slide really ties it all together beautifully. Every single problem we faced, from a slow chef to a power outage, led us to a pizza shop solution that maps directly to a core concept in building huge systems. Vertical scaling, redundancy, horizontal scaling, microservices, distributed systems, and load balancing. We've literally covered the fundamentals just by thinking about pizza.
And it's really important to get this. Everything we've talked about today, deciding to use microservices, planning for load balancers, distributing our system, that's all what's known as high-level design. It's the architectural blueprint. We haven't written a single line of code yet. That part comes later, and it's called low-level design.
You know, at the end of the day, every massive, complex system you use started as a solution to a pretty simple, fundamental problem. We started with one chef and one pizza, and we ended up with the blueprint for a global chain. So the question I want to leave you with is this: what simple problem will you start with?